Today we want to look at a subtopic in algorithms, and the topic is search. In particular, we'll be looking at linear search. So we'll start off by looking at the term searching. What is to search? Now we do that in our homes where you search for your car keys, or you can't find a book that you're reading, you have to search. So you'll be looking for a particular item amongst several items. Now computers store a great amount of data, and a search is a method used to locate a specific item of data from a collection of data items. We have searching algorithms that help us to locate particular data items. So a search algorithm is a step-by-step process used to locate a specific data item from a collection of data items. So search algorithms return a message of success. Suppose an item that you've been searching for is found, you'll get a message to say the item is found. If not, you also get a message to say the item has not been found. So in our algorithms, we usually use the Boolean data type true if the item is found, or false if the item is not found. Now there are different types of search algorithms. So we have the linear search, we have the binary search, we have the jump search, interpolation search. There are so many other types of search, but this video is mainly focused on the linear search. Now, what is the linear search? It's a basic search algorithm used to find a particular element in an array or in a list. Ideally, a linear search is used where your data items are unordered. That means they are not in any particular order. You can also use it if the number of data items is small. If your list or your array is short, then you can use the linear search. Now it's simple and it requires minimal code to implement. We're going to look at the pseudocode later on. So linear search is also referred to as serial search or sequential search. Now maybe just to describe a linear search as to what exactly happens when you're doing a linear search. Now your items will be in a sequence, so the algorithm will look at the first item in the list to check if it's the item that you're looking for. If it's the one, then you're done. However, if it's not the one, it will go to the next item on the list, then compares it with the item that you're looking for, and if it's not, then it compares it with the next one until it has gone through all the items one by one. So if it finds the desired value, it returns the index it found the value at. Maybe if you've done arrays, you know what an index is. It indicates the position or the location where your data item is. So if it searches the entire array or list without finding the value, then a message is given to indicate that the data item is not found in the array. There are several advantages to the linear search, and we're going to look at a few of those advantages. The first one is simple to understand and to implement, and it does not require the data to be stored in a particular order, unlike some of the search algorithms. You don't have to order your data items for you to search for a particular item. Then that number 3 there, I can see there's a mistake. It's numbered 1 instead of 3. But small to medium arrays can be searched relatively quickly using the linear search. So it's fast if your data items are a few. And then there is no need to reorder the list to perform a search after an insertion or a deletion. So suppose you have inserted or a new data item, or you've deleted an existing data item, there is no need for you to reorder the list if you want to search again. Now, linear search also has some disadvantages, and the main one being that it is slow. Remember, I said for you to search for a particular item, you have to compare the item that you're searching with each and every data element. So suppose you have 1,000 data items in your array. That means if your data item that you're searching is on position suppose 999, that means it's going to search 998 times until it gets to the 999th item. So it's actually very slow and time consuming. Now, the last thing that we want to look at is the pseudocode for a linear search. We are going to look at a pseudocode that is using the repeat until loop. So in the pseudocode, I'm assuming that we've declared our variables, we've declared our array. So in this case, we have an array called myList, and this array has 5 data items. You can see the indices there at the bottom. We have 1, we have 2, we have 3, 4, and 5. Those are the indices. And then we have the data items 18, 9, 14, 20, and 11. So the question is, can you do an algorithm to search for 20, for the item or for the number 20? So we are going to use the variables index, and we set the variable index to 0. I'm assuming we've declared it already. Then we have the variable max index. Max index is 5, and 5 is the maximum number of items that are in our list. So you set it to 5. And then we have a Boolean value. We declare the variable as found, and the value for found is false. Now, the first thing that you're going to do is to input the search number. And the search number, like I indicated there, our search number is 20. So input the search number, the user will input 20. Then repeat, this is now the loop. Index is equal to index plus 1. Our index is 0, so it will be set to 1. If myList index, myList, remember, is the name of the array, then index, in this case, our index is at 1. So it means location number 1. What is in location number 1? It's the value 18. So in other words, it's saying if 18 is equal to search number, our search number, we say it is 20. So if 18 is equal to 20, then do that. But we know 18 is not equal to 20, so that will be skipped there. We go to the end if, and we go back to the loop. Index is equal to index plus 1. Our index was 1, so our index is now 2. If myList index, that means second position, so that's 9. If 9 is equal to 20, then no, 9 is not equal to 20, so we have to exit the if statement and go back in the repeat loop. So index is now index plus 1, so our index is now 3, and location number 3, we have 14 there. So it says if myList index, that means if 3 is equal to 20, we know 3 is not equal to 20, so we are going to exit. We're not going to do that statement there. So we're going back in the repeat loop. Index is now index plus 1. Our index is now equal to 4. So if we go to location 4, what's in there? It's the value 20. So if 20 is equal to 20, is 20 equal to 20? Obviously, yes, it is. So if 20 is equal to 20, then found is equal to true. Remember, our found was initialized as false. So now, because 20 is equal to 20, we have found the item. So found is equal to true. And if until found is equal to true, is found equal to true? Yes, all along it was equal to false, but now it's equal to true. Then we go to the next statement, which is if found is equal to true, then you output 20, which is the search number, was found at location 4, which is the index. Else, if you looped and you didn't find the number 20, that means what is going to help you to exit the loop is the statement or index is greater than or equal to max index. Remember, you are incrementing your index there. So if your index is now equal to 5 or is greater than 5, it means that you've gone through all the elements of the array and you have not found a data item that is matching the data item that you're searching for. So it means you use this else branch which says output 20 is not in the list. So that is the linear search algorithm. I'll leave you with a question. Write a pseudocode for the linear search using the for2next loop. Try to do that, and also try to write the same linear search using the while and while loop. That's the end of the presentation on linear search. Thank you.